Second part of 5.1, yesterday we talked about the rational numbers. We talked about how numbers can be represented in simplified form with fractions. Today we're going to be talking about going from decimal to fraction. This is a review of what you guys have had in the past. So you guys have seen this, but not the way that we're going to prove it to explain how to do certain irrational numbers. Not irrational numbers. Wait, we can prove how to do certain decimals that aren't as easy. So, decimal to fraction with terminating decimals. The number to the left decimal, let's get this out of here. The letter to the left of the decimal becomes a whole big number in a mixed number. Numbers after the decimal gets put over the correct value, either 10, 100, 1,000, etc. Number of places after the decimal determines how many zeros you put in. Then you simplify. For example, in other words, if 0.65 as described as 65 hundredths, it is the hundredth place, so it becomes 65. Now, the way that you can see this is read as 65 hundredths, which is the same as 65 hundredths. So as the way that you say it as a decimal form, that's the exact same fraction as you say it. Right? Simple enough. Simple enough. Then, after you simplify it, it becomes 13 twentieths. But what if you have a full number, or a whole number, then a decimal? Such as 2.175. Since the 2 is to the left of the decimal, that becomes a whole number in a mixed number. The 5 is in a thousandths place. Please stop tapping pens and throwing stuff. Or not throwing stuff, making noises. So it becomes 2 and 175 thousandths. So it's read just as it is. Okay? Just as it is. Then after simplifying, it is 2 and 7 fortieths. You with me? Now, that's easy because these guys have an ending. From your book on page 226, example number 2, we are going to find out how to do 0.5 repeating. So what that means is, with your 0.5, what that number looks like as a decimal, you don't have to get out your books, it's right here. What that means is 0.5555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555 and I went through the whole breath last period, but I'm not going to do it this time because I'm being recorded. But it goes 5 forever, all the way until the end of the existence of time. Math will always be there. Time may not be. Well, okay? All right? So it goes on forever. Now, how do we represent that in a fraction? Let's find out. Yes? 5 over 10 is 5/10, which is 1/2. So, I like where you're looking at it, but we're going to figure it out. So, yes, sir?
What would happen if you were saying 0.55555.25555?
That would be a lot bigger of a fraction, a gigantic fraction, actually. The question was, what would happen if they went 555555555 5555555, then we would have to go all the way to where that 2 goes if that does repeat in that sequence. That's much bigger of a denominator that we're going to mess with. So, write this down. We have A. There's going to be 2 parts to this. A, which is 0.5 bar. And we're going to assign the letter N as being 0.5. With the bar over it. Yep, bar means it repeats. And another way that you'll see this, you don't have to write this, so I'm just going to draw it in purple. Another way that you'll see this is going to be like this on homework and whatnot. Like that. That means that repeats. Okay? So we have N equals 0.5 bar, or 0.5 bar. Now, do you agree that if we had 10 of something and you took away one of that something, you would have 9 somethings? You had 10 of anything. You took away one of those some things. You would have 9 somethings, right? Okay. So if you had 10 apples, you took away 1 apple, you'd have 9 apples. If you had 10 baskets of apples, you took away 1 basket of apples, you'd have 9 baskets of apples. So would you say that it's fair for me to say, if I had 10 of these and I took away 1 of those, I would have 9 of those? Okay? No? Yes. Yes. So if we have, I'm going to skip over here. If we have 10 of those and we take away 1 of those, we have 9 of those, as I just asked everyone about 10 of somethings. I take away 1 of those somethings, and I get 9 of those somethings. Yes? No, because it's as a mathematician that you are, you know that by the identity property of multiplication, n is equal to 1 times n. Yes, you are. You took a test on it, and you guys did okay on that part. Tomorrow. Seventh period, sixth period did well. They got an average of 2% more as a class. I'm going to do a competition, by the way, between classes. I'm going to make this quick because we're being recorded. There's going to be a competition. Class that has the highest average as a class gets to the week following the test. You get to only do half of a homework assignment. So if it's odds, you would do like the first half or the last half, that sort of thing. Okay, so that's how I'm going to reward you as a group of wanting to support each other. Just tests. Just tests.
Wait, no, I mean like following the highest. Would it be every? And how long?
Okay, here's what I said. No, listen. It's a test. Each test, like for example, the sixth period has an average of 73.4% on the test. If you guys have a 75.4% or whatever, anything better, and nobody else does better than you, sometime, either this week or early next week, you would have half of your homework given to you for free that day.
Oh, only one day.
Yeah, no, I'm still going to give you guys practice. Okay, back to this. I'd explain more of it, but people who are listening don't really care about what I'm talking about. Let's see if you're stuck or if you're interested in knowing how this works, you'll be able to see it. So we have, yes. So we have 10n minus n equals 9n. Okay, what does this have to do with anything? Do you agree? I'm going to do this in orange. You don't have to do it, or purple. You don't have to do it. Do you agree that if I have the number 3 and I multiply by 10, all it does is move the decimal point over by 1 spot? Do you agree? You should agree because that's third grade math. Now, I have 10n equals 5.555555555555555. Yes? Because I just showed you that 3 times 10 is 30, and 10 times this guy here is going to be this. Okay? Hand up, Raven. This decimal point? Maybe they don't teach you like that. For example, if you have the number 325 and you multiply it by 100, what that does is it takes the decimal from here and it goes over 1 and it goes over 2 because you have 2 zeros. The same way that if you were dividing that would take the decimal from here to 1 to 2. Like that. You guys not learn it like that in 5th grade?
We didn't learn it like that.
Okay. That's all right. See, I haven't taught that because I don't want to teach elementary school. And that's how I learned it in the early 90s. But So we just did 10n minus n equals 9n. Now to go from there, 10n equals what, everyone? There we go. 5.5 repeating. And n equals 0.5 repeating. What's that going to come out to be? 5. Just 5. Just like that. 5. And the reason for this is, if I were to continue drawing this out, this cancel. These all cancel each other out. Everything is canceled out here, so all we have is just a happy solo 5. Okay? So we have 5. And this whole thing here, 10n equals 5, or that 10n equals across here. So we have 9n equals 5. We have 9n, not that one. 9n equals 5. Now I think that you did this toward the end of 6th grade, maybe in the middle. This is algebra, solving 4 variables. What is happening to that 9 and that n? What's happening to that n? What's happening to it, Harrison? It's being multiplied by 9. And how do we undo multiplication? We divide it. Beautiful. So we're going to undo a multiplication by 9, so we're going to divide it by 9. We have to do it to both sides because this equal sign means, hey, they're siblings. If one of them gets money, the other one's going to want money. So we have 9s cancel out. N equals 5/9. And from what we said, over here is that n equals 0.5 repeating. So the answer is n equals 5/9, which is 0.555555555. You just found the fraction for a repeating, non-terminating decimal.
That's amazing.
Isn't it? Isn't it? So, that one was easy. Let's do a harder one. I think I just... B. 3.36363636363636, or if I wanted to rewrite it, I would have 3.36 repeating. Whoa. Yes, you have to write this down. Where? There's room on the bottom back. On the back bottom, there's plenty of room that you won't need. Plenty of room. And then it says there, when there are two, ladies. When there are two, I'd rather me call you. When there are two repeating decimals, you have to multiply, you have to multiply by 100. Did it say by 100? When the two are repeating decimals, you have to multiply by 100. So, just as we did over here, we are going to assign b as a variable, or assign that number as a variable. So let's just keep it normal and go n equals, let's get that a little bit higher. Is everybody done writing that down? Give you another second before I move it up a little bit. 3, 6, there. Oh, that was Pac-Man. So because of what we wrote just there, I'm going to do it by 100. 300 times n equals 336. 36 repeating. 100n equals 336.36 repeating. Tuesdays on NBC. TGIT. Thank goodness it's Tuesday.
Oh, do they eat it TGIF? Like, it's supposed to be TGIF.
And we want to get rid of those guys the same way that we did before. So we are going to do 100 n minus n, which equals 99n. And we have 100n, as we just found out, is 336.36, repeating, minus 3.36, repeating, which equals 3, 3, 3. Hey, keep your passwords to yourself. Right. I don't know, I haven't watched MTV since I was in high school. Yeah, now we know Dana's password. Now, because everything on this side is equal to that side, how do I do that? Because this is equal to that. So we have, don't get restless yet, 99n equals 333. Are you with me, by the way? You seeing how the similarities between this one and the previous example? Yeah. Then we already know how to solve for n, which is divide 99 by both sides. So that would become n equals... No clue.
Is there any easier way to do this? No.
Okay, I'm going to do a mental math sideline here. Okay, this is the sort of thing that you should be able to do away from the horrible third grade lattice method. No, it's easy because third graders can do it. You're seventh graders now. You need to be able to do this stuff in your head. Can you imagine if you were only expected to do what third graders could do for the rest of your life? No. No, you are more capable than that. Lattice method officially banned.
Oh no.
I told you that already. That's enough. Stop. I'm going to show you what you should be able to do in your head. Now, we are trying to figure out how many times does 99 go into 333. You should know that 99 is really close to 100, yes? Okay, so if you do 100 times what? Okay, times 3, which equals 300. Okay, but the thing is, far away from, so we just did the distributive property here. So we did, so we had 100 times 3 minus 3. Yeah, because we had 1, so minus 1 times 3, which equals 297. Okay, so we have 297 have been taken care of 3 times. So we know that we have 3, and there's going to be a 99 here. How many away from 333 is 297? How far away is that? $1 no. What did you say, Lainey? Yeah, she threw me out. He threw me off too. He said dollar money.
Wait. 37?
37, yes. So the correct answer is n equals 3 and 37/99. Oh, not 37, 36. Get out of there. Get out of there. Thank you. 36. And we have to simplify that. Yeah. You should all recognize that the divisibility rules, 3 plus 6 is 9. So since it goes into 9, it's divisible by 9. And you should know that 9 times 4 is 36. So it's 3 and 4/11ths is how you say 3.366363636. Like that. Sorry, Dana, can you see that? Mm-hmm. You're welcome. See, I need stadium seating in here. Wouldn't that be neat? I just build some stadium seating? Yeah. No, I like it like this. I can get around when I'm passing stuff out, and also when you X up, I can reach across and... Okay. Now, you just did that, and it was... Did it make sense? Not really? Oh, too much math in math. Oh. Sorry, let me try to get some more Spanish in here for you. No. Yeah, we'll let Steening and Beavis do that. They do a good enough job. Now, here's what it says. Quiet. Do you notice anything about the solutions before the simplification? Look at the solutions before simplification. I had to, sorry.
Wait, I don't know what that means.
Doesn't know what that means. Let's do here. Simplification. Before simplification, we had... we'll go bright green. Let's see. We had, here's simplification. Oh, here, this one wasn't simplified. N equals 5/9. This one was 3 and 36/99. What do you notice about those two before? Yes? They're what? Yes, they are fractions. That's the idea. However, what do you notice about them? What do they have in common? Johanna, what do they have in common? You with me? Were you with me? Okay. Please stick with me. Max, I know that paper probably looks like it tastes really good, and it might even, because I think you were just eating it. I know, I love math too, but, I love pizza. I love eating pizza, but I don't love eating math. Okay? What do you notice about them? Think of the denominator. What do you guys notice about those? Laney! Yes! They both have a 9. Yeah, we are all thinking it, I think. Right? Now, what do you notice about them? They all have something to do with a 9. And what we can do here is it says the denominator will be 1 less. 1 less than the place value of the decimal. Then simplify. So either 9, 99, 999, 9,999, etc. Whatever it is, that's what it's going to be whenever there's a repeating thing. For example, number 1, 0.3 repeating. The 3 is in the tenths place. So if it was just this, we could have 3/10. But it isn't just 3, it's this, 3 repeating. So that goes away. That can't be it. But since it is repeating, 1 less than the 10 is 9. So it becomes, I did that earlier too, becomes 3/9, which simplifies to 1/3.
So if it's like 30, would it be 90?
30 repeating?
Yeah.
No. 30 repeating would just be 3 repeating. Or no, actually 30 repeating would be this. It'd be this. It'd be 0.30.
So then it would be...
Hold that thought for about 15 seconds, okay? We're going to come back to this guy. We're going to come back to this. So it says, example number 2, 19 or 0.19 repeating, or 19 hundredths repeating. 9 is in the hundredths place, but since the fraction repeats, 1 less than hundredths is 99. So it becomes 19 over 99, which is already in simplified form because 19 is a prime number. To answer Laney's question, 0.30 repeating is going to be equal to 30, and since this here is in the hundredths place and it's a significant figure there, it matters. This one is also going to be 99, which simplifies to 10 over 33. Yes, sir?
So the denominator is always going to have a 9?
When it repeats, yes. As it says here, the denominator is always going to have one of those in it whenever it repeats, depending on whatever the smallest part of the decimal is repeating. Some practice. Okay, this is going to be super quick because these are super easy because we already did the hard part. O-Town, what's number 1?
In fraction form?
Yep, fraction form. 4/10, which simplifies to what? 2/5. Good. I'm going to circle that. Good. How about number 2? Abby. Yeah, it's just 23 over 100. Because she hadn't said anything yet, and I didn't want to start writing before she said anything. 23 over 100, and can that be simplified at all? No. Why? Yeah. Which 100's a prime number? Oh, good. 23 is a prime number. Good. All right, now we have one like this, number 3. Boom, boom, boom. Sam. 25 over 99, he says. Raise your hand if you agree with him. You should all get your hand up because he is correct. 25 over 99. Because this 5 here is in the hundredths place, so that means we go 1 less than that, 99. So that's how quick we just did this one when it took us 10 minutes to do the other ones?
So we learned.
That's ooh, you are correct. You did learn. I like it. Okay. Next one, 2.34, Jace.
2 as a whole number and 34 over 100.
34 over 100, good. And because I know my math facts, I know that 34 is twice of 17. Okay. Freddie, can you help me out with number 5? Can you tell me what I need to do here? Then Max, you can help me with the next one. Good. This is in the tenths place. I'd like you to talk about what you're saying. Good. Denominator's 9. Uh-huh. Beautiful. And the numerator's 8. What he said was he knew that the 8 that's being repeated is in the tenths place, and he needed to subtract 1 from the 10th place, so he made it whatever over 9, and it became 8 ninths. Okay, Max, what am I going to do here? How far is it repeating? What's the last repeating digit here? Yeah, but where is that 3? What's the 3 that's being repeated? Is it? Ah, yes, the first one. That's the only one that really matters here, right? And as far as we can know, the pattern isn't going to go 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 2. Okay? Sounds like a current pop song. All right. So we have Dish, good. Then where do we go? 3 over 99. Didn't you say that it was just the 3 that was repeating, not the 33? Ah, 3 over 9. There we go. Boom.
Mm-hmm.
Simplify it. How do we simplify it? 1/3. You're going to have to compare. Now, here's what you're going to do when I'm passing out the homework. The homework is, the papers I'm passing out, 5.1 rational numbers. 5.1 practice, all visible things that you're going to have, that is your homework. I'm going to write down the answer to these. I want you guys to work on them here and at home. Pause the video, and it'll be up there. I'll show my work. Yeah. So you guys are working on this right now, and I'm going to pass out the homework. So don't look up here until you're done with those three. Don't ask questions right now. I want to see if they come up after you answer these for yourselves, okay? So do 7, 8, 9, everybody. There you have it.